Scientific gyros are beautiful things like this in gimbal rings that maintain their axis of spin, but the real magic lay in the toy gyroscope, the one you've seen come down the string. Toy gyros are usually supplied with a little Eiffel Tower model, and one of the standard tricks you're supposed to do is to spin the gyro, put it sideways on the tower, thus allowing the force of gravity down on that to be reacted by a normal force from the top of the tower. So you're putting a torque on about a horizontal axis, and that will make the gyro precess about a vertical axis, and everyone is amused. And no one takes it seriously because it is, after all, a toy, isn't it? Fine. Most interesting demonstration. Let us just weigh these two things. First of all, we will weigh the gyroscope. Where's the yard there? That's it. We will weigh the gyro, and we find it to be 310 grams. There are 312 grams. We will weigh the tower and find it to be less than a gram. So over 300 times the weight of the tower. Now, haven't we missed something? Thank you, Bill. What did we miss? We missed the fact that if you ever try to rotate something which is eccentric, not symmetrical, you tend to... Yeah, somebody knows, they've tried. You tend to shake your bones to pieces. Now, what is happening when I do that, apart from me getting in terrible shaking, the whole of this is trying to retain its center of mass fixed. Let us look at the gyro again with that sort of thought in mind. Surely 300 grams compared to 1 gram, you would expect the 300 grams to want to stay in the same place, and you'd expect it to move the tower around itself. But of course it is our common experience that although that happens, the gyro on the tower does not make the tower go round the gyro. 300 times the mass. Whoops. Sorry about that. Can you screw back in his bearing? Friction on the table. I can hear my critics now. He has friction. We thought we would remove as much of the friction as we could by spinning it on ice. Yeah. Oh, it's come off the tower bill. All right. We estimate that the coefficient of friction between the tower and the ice is about 0.02, which is just about as small as one could expect to get without going to something exotic. It's a little bit tight on the bearing, Manny. Could you give me the pliers? Did you do it up with your fingers? Yeah. Oh, it's all right, I can manage. Just a wee bit tight on the pivot. Ah, thank you, man. This, of course, is an adjustable gyro. This belongs to an earlier age. Nowadays, they make the flywheels out of aluminium, and what better metal than something that's one of the lightest we know for making a flywheel. So, there it is. This is the modern high standard of living. This is an old-fashioned gyro, about 30, 40, 50 years ago. We have some gyros here today that are 100 years old. So here's a thought. This thing has been with us for 100 years, and we haven't noticed those things which we might have noticed. A tower on ice. Are you convinced? I was.